Hi friends, you are welcome back to another interesting question. We are asked to calculate the area of this semicircle. We have this line segment congruent with this and this. Their lengths are a each. The length of this is x, while this is given to be the square root of 2 root 10 plus x multiplied by 2 root 10 minus x. So how can we solve this? How can we calculate the area of this semicircle? It is very simple. A semicircle is half a cycle, so the area of the semicircle is half that of its cycle. Area of a cycle is calculated by the formula pi r squared, where r is representing the radius. Here we see this is the diameter of the semicircle, and its length is divided into 3 segments of equal length A. Diameter is 2 radius, so 2r equal to 3a. Divide both sides by 2. It will be r equal to 3 over 2a. Substitute it here. 3 over 2a all squared is 9 over 4a squared. 1 over 2 times pi times 9 over 4a squared is 9 pi a squared all over 8. So area of semicircle is 9 pi a squared all over 8. Okay, let's come here. Label the points. This line QS, let's assume its length to be y. So we have y equal to square root of 2 root 10 plus x into 2 root 10 minus x. Square both sides of the equation. Here square root eliminates square. 2 root 10 plus x times 2 root 10 minus x is 2 root 10 into 2 root 10 minus x plus x into 2 root 10 minus x. 2 root 10 times 2 root 10 minus x is 40 minus 2x root 10 plus x into bracket 2 root 10 minus x is plus 2x root 10 minus x squared. Minus 2x root 10 plus 2x root 10 is 0. So it is 40 minus x squared. Therefore, y squared equal to 40 minus x squared. Take negative x squared to the left. So y squared plus x squared equal to 40. That is x squared plus y squared equal to 40. We keep this equation aside. Now look at this triangle. It has its sides to be of length x, y, and a. We assume the size of this angle to be h. Then use the cosine rule on the triangle. By the cosine rule, we know for a triangle ABC, a squared equal to b squared plus c squared minus 2bc cos A, where A is the angle facing side A. So here, if we assume this angle to be A, this must be side A, and yes, its length is A already. If we let this be B, this must be C. So A equal to A, B equal to X, and C equal to Y. Angle A is H. Substitute it here. So a squared equal to x squared plus y squared minus 2xy cos h. Take this to the right. So a squared plus 2xy cos h equal to x squared plus y squared. We already have x squared plus y squared here to be 40. Substitute it here. So a squared plus 2xy cos h equal to 40. We keep this equation aside. Now come to this triangle. We have this angle to be h. Assume the size of this angle to be c and this d. We know the summation of angles in a triangle is 180 degrees. So based on that, c plus d plus h equal to 180 degrees. Now this semicircle, Since a semicircle is half a cycle, we draw out its complete cycle. Now from this point, draw a side parallel to this side down to the circumference. Since they are parallel, and this make angle D with this side, the angle between this and this must also be D. Look at this arc. It subtends this angle D such that this side is 2as, that is 2/3 the length of the diameter. Same is for this arc also. It subtends the same angle D, and this side is 2/3 the length of the diameter of the cycle. Therefore, the two arcs are congruent. Hence, this side and this are also equal. So since this is y, this must also be y. Call this point V. From point V, draw a line segment to this point S. Now look at this triangle. Two of its sides are of length A and Y, and the angle between them is T. Same is here. Two sides are of length and the angle between them is T. That fulfills the criteria for the congruency of two triangles, which is SAS. So the two triangles are congruent. Hence, this side and this are also going to be congruent. So since this is x in length, this must also be x. Let's look at this quadrilateral. We observe something unique. Opposite sides are equal in length. This is a property of a parallelogram. So therefore, the quadrilateral QRVS is a parallelogram. This is its diagonal. We draw the second diagonal. Another property of a parallelogram is that its diagonals bisect each other. So this diagonal bisect this. Therefore, this segment and this each are half A. This is the midpoint of this line. If you look at this diameter, the same point is also the midpoint of the diameter. That implies that the point is the center of the cycle. So we see this diagonal QV passes through the center. Therefore, it is a diameter. So its length is 3A. Therefore, line QV equal to 3A. Let's look at this triangle. If we use the cosine rule, taking this side as A, this must be angle A. And if we take this as B, this must be C. So A equal to line QV, which equal to 3A, B equal to X, C equal to Y, and angle A equal to C plus D. Substitute it here. So 3A all squared equal to x squared plus y squared minus 2xy cos C plus D. 3A all squared is 9A squared. Come back here. C plus D plus H equal to 180 degrees. Take H to the left hand side of the equation. So C plus D equal to 180 degrees minus H. Take the cosine ratio of both sides. Here, cos 180 degrees minus H, we know from trigonometry, the cosine ratio of 480 degrees minus an angle is the negative cosine of that angle. So this is negative cos H. Therefore, cos C plus D equal to minus cos H. Substitute it here. Minus 2xy times minus cos H is plus 2xy cos H. So 9A squared equal to x squared plus y squared plus 2xy cos H. Recall here, x squared plus y squared is 4D. Substitute it here. So 9A squared equal to 4D plus 2xy cos H. Bring this to the left. So 9A squared minus 4D equal to 2xy cos H. Therefore, 2xy cos H equal to 9A squared minus 4D. Come to this equation. Replace this with 9A squared minus 4D. So a squared plus 9a squared minus 4d equal to 40. Take negative 40 to the left. A squared plus 9a squared is 10a squared. 40 plus 40 is 80. This 80 divided by this 10 is 8. So a squared equal to 8. Substitute it here. 8 cancels 8. So area of semicircle equal to 9 pi square units. Thank you for watching. Please like, share and subscribe, and also turn on notifications. Thank you.